Hello, everyone, and welcome. This is Professor Thayer with you here today to talk to you about the if statements. So we're actually going to talk about this over the course of the week. We will be taking a look at how to make decisions on the computer. So when you write your code, you may want to do something contingent upon some certain situation that happens. We have this in everyday life, and we use if statements in English all the time. And the great news is that a lot of how the logic works for if statements in programming is very similar to how it works when we are using if statements in everyday life. So with that, let us go ahead and get started. I'm going to share my screen, and as usual, you are free to follow along or to go and get your slides for yourself. So let me just do this and bring up our presentation. So flow control with if statements. Flow control means how the program is moving. That imaginary pointer is what I have in mind. So we will actually talk about flow control with regard to several things. We will also see looping of several different flavors in the upcoming weeks. So this is a bird's eye view of our if statements. We're going to take another look at input, which will be important because we might want to ask the user to provide some input, and then contingent upon what they say, we might decide what we want to do. We're also going to talk about dummy proofing the code in edge cases. We always expect that our users are going to do what we ask them to do, but not everybody does. And as the responsible programmer, we're the ones who are responsible for making sure that the code always works. And so there are those exceptional cases, those edge cases that we're going to need to handle. So we will be taking a look at that. We'll also be taking a look at the simple if statements. And then, which is just if, and then you provide a condition. But there's also a variety of other situations with these statements. So we will also take a look at which other ones of those are available, so that we can also see how we can code those up. That'll be the alternative execution, the chained conditionals. And then in the last lecture, we'll take a look at the multiple alternatives and the nested conditionals to see the full spectrum of what you can do with the if statements in programming. So let us go ahead and delve into this. So we've already seen input. So this will be our second look at input. Recall that the input function is used to obtain the user's input, and that this gets it as a string, which is great. Unless, of course, you need the user to type something like, please type a number, and you can only get a string. So how are we going to use that as a number? That could get to be a problem. So in parentheses and quotes, we're going to specify the prompt to display to the user, such as a question, like what day of the week is it, right? We might want to ask the user some question, and then they're going to type something back. If we don't give them a prompt, how will they know that we're waiting for them to type something? Otherwise, the program will simply just pause, expecting input, but the user doesn't know it. So that's why we have that prompt. The program pauses to wait for the user to type the input on the terminal, and then when they press enter, it continues on, gets their input, and it returns that to the program, which we then can capture in a variable. We would set a variable equal to the output of the input function to capture the user's answer. So we'll have the syntax of a variable equals input, and then the prompt text, just like this question up here. Today is equal to input of what day of the week is it, right? And then it's going to print out the answer. You said today is, and today. So what day of the week is it? And the user here is typing Tuesday, and you said it is, and then it's responding Tuesday. User input, we're going to use the input, which always gets the type string. So that's great, but it's also a bit of a limitation, maybe even a bit of a problem. The input gets the user input of type string. So if we say x equals input, please enter an integer. And so here we're running this interactively, and the user, in fact, supplies an integer. We picked 3. And we say, Python, what's x? And Python says, well, it's 3. You typed 3, I put it into X, just like you said to do. Here it is. It's a string because input gets strings. And if we do type of X, sure enough, we see that the type is of string, but we really wanted an integer. So what could we do about that? What if I need to get an integer? Well, there's a couple of ways we could get around this. The first method would be to obtain the input as a string and then use the variable reassignment to overwrite the variable into the new type. We would use the conversion function to convert from a string to the integer. So let's just take a look and see what this might look like. So step one would be to get the user input as a string, which it's going to do anyways. So you just do x equals input, please enter an integer. So even though the user is expected to enter an integer, it will come out as a string, as we've seen, and we can verify this. So they have in fact typed something that could be an integer, but when we ask Python about X, sure enough, it's reporting it back as a string, and then we do type of X to verify, yeah, Python's got it as a string. So there's the problem. Now we go to step two. We're going to perform an explicit coercion to convert from the string to the integer. So here's my coercion right here. I'm going to use the int coercion because I wish for it to be an integer. So I'll do int of x. Now, if x is the string of 3, do you think that it would be able to convert that into an integer? Yeah, that seems like an okay coercion to me. Python should be able to figure that one out. And so then x will get the value of the integer version of x. And then we ask Python, what is x? And now it tells us 3 with no quotes. So things are certainly looking better, and we can verify that it is indeed an integer by using the type of x, which confirms that it is in fact class int, which is terrific. Now, the reason why we call this variable reassignment is because x already had a value. X had the value of the string of 3 up here. And down here, notice that we have now converted it into a new type. This is that idea of dynamic typing that we talked about previously. So we see that x now has a new value. So it's still 3, but it was 3 the string before, and now it's 3 the integer. And so the reason why we call this variable reassignment is because the variable has already been assigned another value before we have overwritten that value. That's something we'll see pretty often as we're cycling over programs, that we can take the value of some variable and update it to something new. And that's the variable reassignment that we had talked about in the week 2 when we talked about the variables. So this is a nice little bit of code that does illustrate a couple of different things that we've already talked about. So there's also another way that you could use the coercion function to convert it into the desired type. So you could do something like this. You could do x equals int of input, please enter an integer. So what this is going to do is it's going to use composition. We recognize this because there's multiple functions here, one inside the other, just like we could do with composition with the math functions. So again, the idea is that you work from the inner parentheses to the outer parentheses, just like you do in order of operations, and the same rules with parentheses apply to Python, although they're not necessarily mathematical expressions. It could be a different kind of an expression, such as input, please enter an integer. So here's our inner function. Please enter an integer with input, right? So this will execute first because it's the inner parentheses, and then whatever they enter will get returned out because that's what input does. And that will get returned into the int function, whose job it is then to convert it into an integer. So when we look at how this actually executes, we can see evidence that that's really what's happening, because at first it will say, please enter an integer, even though this is the inner function. So the inner one goes first, which is what we see here. And then they type 3, great. And so then that gets passed into int. So then when we say, Python, what is x? It says 3. Notice that it does not have the quotes on it. So that's looking promising that the type is correct. And then we should always verify, right? It's always a good idea to check your work. So you say, Python, what is the type of x? I think it's the integer, but I just want to know what you think it is. And so we do type of x, and we see that it reports back class int. And so we can then confirm that we have correctly converted the type. So this shows you a couple of different ways that you can do that change from one type, the string, from input into an integer. Now, suppose you need to get a float. Okay, well, as you might be guessing, you could do this a lot in the same way. So we could do it again using the two steps, first getting the input as a string, then reassigning the variable with the coercion function. So we would see a very similar pattern. So get the user input as a string. So we do x equals input, please get a floating point number. They type some number, and then we do ask Python what it is. We see that it sure looks like it's a string, and we verified that it is. Okay, then we need to proceed to step 2, which is to perform the explicit coercion. So here's the float explicitly written here, right? Implicit coercion is when Python does it without us actually calling the coercion, but there we can just get, we can get this by doing the explicit one, which we see because we've in fact actually typed float here. So that's explicit coercion to convert from the string to the float. So that should become a float now. And again, we have variable reassignment because X has already been assigned to something. And this is also dynamic typing because it used to be type string and now it's type float, or at least we hope so. And then in this line right here, we can demonstrate that yes, in fact, it is a float because I just did type X, which shows us it is a float. We can also do the coercion function with the composition to convert the type of the input directly. So here we are going to, again, do the composition, but instead of using int, we're going to use float. So we have input, please enter floating point number, embedded inside of the float coercion function. And so then we ask them to type a number, and they do, which is a legitimate float if it gets the correct type. And then we check to see if it has gone through float to convert it to the float. And we see that it looks like it has, and we can verify that sure enough it has, because it is right here with the type. All right, so that's great. That's how we can deal with those kinds of things. But there's also some other things we're going to need to deal with. And this is going to raise the idea that we may have some cases, some if cases. So if the user does this, or if this situation comes up, that we may need to, in fact, do something about that. And so there's this idea that as the programmer, the onus falls on us to write good code, even if you get what I'm going to call the dummies, right? You know, I'm sure you would never do these things, but you never know who's going to get a hold of your code and what they're going to type, or if somebody's going to be a wisecrack and, you know, try to break your code. Hackers, you never know who's going to come and use your code. We always have to make sure that the code is going to be robust and strong so that nobody could crack our code and make it fail. And oftentimes these happen when we work with the what we call the edge cases, those special conditions. So as a programmer, it's your responsibility to write the good quality code. Users may not always follow the instructions, even though you may tell them, you know, please enter a float, you know, and then they type O-N-E, point, P-O-I-N-T-F-I-V-E. Well, not quite what I had in mind, right? So you'll never know what they're going to do. If the code fails to execute properly, or worse, it crashes, even if the user does not follow your instructions, the culpability still lies with the programmer. So it is our responsibility to make sure that code is really good. Therefore, it's necessary for a good coder to anticipate what could go wrong by considering all the possibilities and making provisions for this. This is very similar to how we think about math problems. And if you've done any pre-calculus, you've probably talked about some of the situations that could cause functions to fail. That is, functions could have, you know, division by 0, or other problems could come up, holes in your function. And so the thinking in computer science is actually a lot similar to how it is in math, even to the point where actually at Wesleyan computer science and math are kind of the same department, and at a lot of schools that is the situation. So that's why we have this kind of a mathematical thinking kind of a flavor to computer science. And you'll see as you go on in your studies that that actually is very pervasive throughout how computer scientists think. So if therefore it's necessary for a good coder to anticipate what could go wrong and consider all the possibilities. We could, for example, ask the user to re-enter their choice, or to make a variety of ways that the input could be processed. So all of these things then are preempting if conditional statements. If the user entered, you know, something that's not valid, if the user has supplied something that's valid, but maybe is an outside, like they're supposed to enter an integer, but you wanted it to be positive and they entered a negative one. What are you gonna do? You're gonna have some if statements to check the input. And there, of course, are the reasons why we would have if statements as well. So that brings us to the idea of the edge case. The edge case is a case which is usually rare, shouldn't be showing up all the time. Like most of the time, hopefully people are following the instructions, and if you say, you know, use positive numbers, they're actually going to do it. But if it does happen, it requires attention, because if you don't deal with it, your program might crash. Often it refers to situations where the user input is involved and we cannot predict what the user will type despite providing the instructions. So edge cases often do or could or are likely to cause problems, and is not always immediate. It could be further on in the code, and that makes it even harder to debug. So we need to consider all the possible cases, including the edge cases, when we write our code, and how to handle them to dummy-proof our code so that it's not going to crash. Edge cases should be noted as preconditions in our functions. So we had mentioned that there are those three parts to the doc string. And so when you have a precondition that is, you know, x should not be less than 0, x should not be equal to a particular number, or whatever the situation is, you can mention that in the preconditions. But of course, as a doc string, being a string, it's not, well, it is a comment. The string is a comment, and it's not actually executed by Python. So that comment is really more for the users of the code and your future self and anybody else who might be coding with your code. But we still need to deal with that. Okay, so let's take an example like this. See if you can spot any problems here, any potential problems. And you see we have a bug here. Something could be wrong. Okay, so when I'm looking at this, I'm just saying, okay, my division of x is taking an integer and a float, and it's returning a float because there's division, so it makes sense. Yeah, that's good. Divides 1 by the value of 3 minus x. So once I see division, I'm always worrying about division by 0. Is there a way that I could get division by 0? Right, if x is 2, is that fine? 1 divided by 3 minus 2. What's 3 minus 2? It's 1, so it'll be 1 divided by 1. Okay, that's fine. Oh, 0. That might be a problem. Let's see. 1 divided by 3 minus 0. So this would be 3. 1/3. Well, it's a non-terminating decimal, but it's not a problem. How about a negative number? 1 divided by 3 minus -5. Minus a negative is the same as plus a positive, so that'll be an 8, right? So 1/8, that's okay. And my division of 3. Y equals 1 divided by, 3 minus 3. The denominator is going to be 0, and that one is going to cause a problem. So there's all kinds of numbers you could put in here: positive, negative, 0. Even 0 is not a problem here. The problem is specifically when you enter the number 3, because this causes this expression to become 0 in the denominator, which gives us the division by 0 problem. So we have identified an edge case. Most things work, but there is this one particular one that's not going to work. So what can we do about it? All right, well, so we're going to need to deal with that. So some of the things is that we're going to put in the precondition. So I've updated the doc string, so the line under the signature now has a precondition, all x except for 3, because 3 is the problematic one. Then the other thing that I'm going to do is I'm going to put in an if statement. So of course we haven't looked at the syntax of this yet, but I think you can get the idea that an if statement is in order here, because if x gets the value of 3, specifically only that value, then we will need to print an error, and we should not continue, because if we try to execute this line right here when x is 3, then we're going to get a problem. So what we're going to do is simply terminate the code with a return after we've given the user some error message so they understand why the code is stopping. And so by returning here, remember that terminates the execution of the function, so it never executes down here if it goes inside the if block. Double if there. And if there's not a problem, again, if it will simply just proceed right like so, and it will do y equals 1 divided by the 3 minus x and return the answer. And these would not cause any problems, and our edge case will be dealt with. So that does motivate our need for if statements, as well as other reasons too, reasons why we might just want to say, if something happens, we should want to have an if statement to handle it. So let's take a look at what a conditional execution is all about. Conditional means upon a condition. If it's raining today, if it's good weather, if it's, if I had $1 million. When something is to be done contingent upon some condition, that's when if is in order. We're going to use the Boolean type to decide, because we need true or false. That's what Booleans are all about. So we're going to use an if statement. A branch guard determines whether it will run. So we'll have a Boolean to evaluate true. So if the Boolean evaluates to true, then that branch will run, and otherwise it will not run. So let's take a look at what this would actually look like. Here's our syntax and example. So if, and then we would have some Boolean expression here, which is serving as our branch guard, right? So the branch means basically the body of the if statement, the indented block to be executed. So it's guarding whether or not we can get into the branch code or not. So if the Boolean expression is true, then we do go in and execute the things in the branch. Otherwise, if it's not true, we do not execute it. So let's see an example of what it would look like. We're going to get user input and coerce to float. X equals float of input, please enter a number. So we've seen this before, that's fine. Here's a conditional statement execution. If X is less than 0, so if they typed a float that's less than 0, it will print X is negative and it's going to compute the square, right? So there's several things. This body happens to be pretty large. X squared equals X times X, and then it's going to print the square is positive, and it's going to actually report out X squared is and that actual value. If X is not less than 0, then this will never execute. But if X equals 0, well, it's not less than, so again, it would not execute. It only executes if X is less than 0, just like it sounds. So just a quick refresher on the Boolean expressions. The value of Boolean expressions is going to either be true or false. Remember that you need to use the capitalization in Python, and if you put it in quotes, it will be type string, so you need to do it without the quotes. So here 5 equals 5 is a true expression, whereas 4 equals 5 is false. So remember, we're using the equals to do the comparison. If you use a single equal sign, that's the variable assignment. So if you say 5 equals 5, that's trying to be a variable assignment in terms of what Python is thinking, not really what we're trying to do. True and false have the type bool, and we can use the relational operators. This is equal to, the not equal to, greater than, less than, greater than, equal to, or less than or equal to. The condition of an if statement is expressed as the Boolean expression, which is why we're reviewing it. So now let's take a look at the body of a conditional. May have one or more statements. There's no maximum number, I mean, aside from your hardware limitations, but you'll be typing for a very long time before you ever meet that. Be sure to indent all the statements belonging to the conditional. So see how we have if today equals Tuesday, right? This is the part that goes with that conditional. And here's a second conditional, if today is not equal to Tuesday. Oh, and we have that past that we mentioned, meaning that it will go past this without an error, because if you just left it empty, there'd be an error because there's nothing there, and if is expecting an expression. So pass is the expression that does nothing. So we will put that there as a placeholder because we might decide something to do later on. So be sure you do your indentations correctly. So the body or the branch of the if statement should be indented relative to if. Just press your tab key. And here we have if, and then this one also is tabbed in. Just as a tip, I'll mention that in Python, tabbing and using spaces and the same number that's equal to your tab is not equal in the eyes of Python, because multiple spaces is not the same thing as tab. So it can be confusing if you tab things in. You need to be sure to not use your space bar, but just use your tab button instead. If you do use your spaces, Python will not recognize them as being at the same level. And even though it visually appears to be correct, it may not be. So just pay attention to that. Use past as a placeholder if you do not yet have a statement. So here we haven't decided what we're going to do yet. And so here's the execution of this. What day is today? And we provide some suggestions for them as to what's typed. Oh, I think we haven't seen this before. This is the /n. This is for the new line. So what the /n does is it causes the cursor to come over to the next line. So when they're typing what day it is, we notice that they typed it on the next line, and that's because we had the /n. It doesn't print anything, it just moves the cursor down. It's like pressing return, kind of. And so here we're illustrating the call of the, so this is the execution of the function from its script. Here we're showing an alternate way that you can run your code, and that is after you've loaded it in, you can just do your function call from the interactive interpreter. So what day is today? Again, it says, and the user types Tuesday, and then it says, it's your favorite day, Comp 112 lecture, yay. So hopefully you're excited about going to your lectures. This is probably on a Monday for many of you. Our other lectures in college consistently are only on Tuesdays, and they have to sit through all the lectures. So that's why I have this little info here for them. Okay, so we're going to use the Boolean expression to write a condition. In English, we would write, if today is Tuesday, then there's a Comp 112 lecture. What would the corresponding code look like? Well, so here is our sample output. We would do something like this: when the condition is met versus when the condition is not yet. If today equals Tuesday is the conditional statement. And so then we could see what would happen if they have typed Tuesday, right? So here we have a variable set to Tuesday, and if today is equal to Thursday, then we see that it is not equal to Tuesday, so it does not print this out. In fact, there's no visual output because none of the print statements, well, the only print statement does not execute. All right, well, so then that is our introduction to the if statements. Hopefully that's given you an idea of how they work, which is a lot like how we use if in everyday language. So I hope this has been helpful to you, and we look forward to seeing you the next time. Bye-bye.